Okay, in the last class we have discussed about the interconnection network. Okay, in the interconnection network we have the two types. Okay, interconnection networks. Okay, what is the necessity of having the interconnection? Interconnection plays a crucial role. Okay, crucial role in order to get the performance, in order to get the high performance. Okay, usually we'll connect the devices. Okay, usually we'll connect the switches, or usually we'll connect the cores, whatever the functional units. Usually we'll connect with the help of what here the buses. Okay, usually bus is made up of parallel wires. Okay, parallel wires which are used to communication between the one unit to another unit, and even at the end of the bus we have some hardware. Okay, these hardwares will help us to connect and even process the data between the two modules. Okay, whatever the cores are functional units. Okay, and even instead of usually we use the buses. Okay, everywhere we'll be using the buses. Okay, buses will be very cheap in cost. Okay, very low in cost. Okay, this is the main advantage of the bus. But thing is that if you want to connect the more than the 2 to 4 cores, one another with each other, then we'll go for with the switches. Okay, switches. Okay, switches will have the buses will have the two phase. Okay, left side, right side. Okay, left side and right side. But the switches usually will have the more than 4 phases. Okay, more than 4 phases. Okay, this is called the switch. Okay, this we call the switch. Okay, this can have the more than 4 switches. Even you can connect these switches can also use to connect the processor or cores or even memory units with the help of the extra. Okay, even I can use the fifth connection also. Okay, switches will give the higher flexibility, but the buses will not give the flexibility, and also high performance will not get. Okay, usually the performance of the buses. Okay, if you connect the more than the 2 to 4 devices, 2 to 4 cores one another with each other through the bus. Okay, there will not get the high performance, and also even will not get the flexibility also. Okay, in order to get the good flexibility and the high performance, we'll go for the switches. Okay, switches will have the 4 phases, 4 connections, and even I can use the switch to with the help of the even with the fifth also. Okay, there are 2 types of switch configurations. One is called as the in the last class we all discussed these things. Okay, I am recapping. I am giving some idea about the last class. Okay, because so many students were absent. Okay, these are the 2 configurations. Okay, I can use for switching purpose. Okay, I'll be using these 2 type of configuration for the switch purpose. Okay. I will be using these 2 types of switch configurations in order to get the connection between the memory units and also cores also. Okay, the best example for the switch is what here the crossbar. Okay, crossbar. Okay, this is the crossbar. Okay, usually we'll have the crossbars will connect if you want to connect the more 4 memories and 4 processors with the help of the switches. Okay, we can use the crossbar. Crossbar can give the 4 connections, one switch. Okay, use the example for this switch is what here the memory 1. And also memory 1, memory 2. Okay, even the processors can also be connected with each other parallelly with the help of the switches. Okay, how the switches are made? With the circles. Okay, circles. Okay, circles. I have the circles. Okay, these circles are nothing but the switches. Okay, these circles are nothing but the switches. Okay, whatever I'm using interconnection. Okay, one to another with the help of these links. Okay, these are the links. Okay, these are the links. Okay. Okay, I will be connecting these processor units also, P1, P2 cores also, with the help of the switches. With the help of the switches. Okay, these are the this is the main diagram of the okay, shared memory crossbar system. Okay, we can use, okay, this can also be used for the switching. Okay, okay, switching purpose also. Okay, main advantage of this bus crossbar switches is they will give the simultaneous communication between the one processor to the memory, one processor to the memory, and also we will get the cost of the switches is somewhat more. Okay, this is the main disadvantage, but we can communicate with the one another. More devices we can communicate with the help of the switches, with the help of the links. Okay, okay. There are, I have already told you that there are two types of interconnections. One is what, shared memory connections, another one is what, distributed memory connections, interconnections. Whatever I explained till now, this is all about the shared memory interconnections. Okay, now I'll go to the distributed memory interconnections. There is, in the last class I stopped here only, but today we'll continue by this only. Slow on that. Slow ಹೇಳ್ಬೇಕಾ? Okay. ಸ್ಲೋ ಹೇಳ್ಬೇಕಾ? ಹೌ ಮಚ್ ಶುಡ್ ಸ್ಲೋ? ಓಕೆ, ಎಷ್ಟು ಸ್ಲೋ ಇರಬೇಕು? ನಾನು ಎಷ್ಟು ಬೇಕಷ್ಟು ಸ್ಲೋ ಹೋಗ್ತಿದ್ದೀನಿ, ಇನ್ನೂ ಸ್ಲೋ ಹೋಗಿರ್ಬೇಕಂತ ಹೇಳ್ತೀನಿ ಆಯಿತಾ? ಬಟ್ ಡೋಂಟ್ ಮೇಕ್ ನಾಯ್ಸ್. ಓಕೆ, ಪ್ಲೀಸ್, ಐ ಆಮ್ ರಿಕ್ವೆಸ್ಟಿಂಗ್ ಯು. Okay, next one I am considering here the distributed memory interconnections. Light ಆಗಿ ತೊಗೊಂಡ್ರಲ್ಲ ಸರಿಗಲ್ಲ. Okay, one is what, shared memory interconnections. Okay, and also we have the distributed memory interconnections. Okay, as I already explained this one. Okay, okay, whatever I explained till now, this is all about the shared memory interconnects. Okay, now I will go through the distributed memory interconnections. Okay, okay, in the distributed memory connections usually we have the two types. Okay, one is what, direct interconnects, and also next one is indirect interconnections. Indirect interconnects. Okay, in the direct interconnects usually we'll do the switch. Okay, switches can be easily we can connect, switches can be connected to the memory and processor directly. Okay, without any interventions. Okay, we'll be using the, and also we will be connecting the switch to switch also. Okay, usually the processor and memories are connected to the with the help of the switches. Okay, will be done with the interconnects. Okay, links. Okay, these links can be also be used to connect the link to link each other. Okay, links to link. Okay, this we call as the direct interconnects. Okay, direct interconnects. Okay, usually we'll be seeing the, we can explain with the figure 1. Okay, okay, ಯಾಕೆ ಮಾತಾಡ್ತೀಯಾ? ಇಂಟ್ರೆಸ್ಟ್ ಇತ್ತು ಕ್ಲಾಸ್ ಅಟೆಂಡ್ ಮಾಡು, ಅದರ್ವೈಸ್ ಯು ಕ್ಯಾನ್ ಲೀವ್ ದ ಕ್ಲಾಸ್. ನಾನು ಹೇಳ್ತಾ ಇದ್ದೀನಿ, ಸುಮ್ಮನೆ ಕೂತ್ಕೊಂಡು ಒಂದು ಅರ್ಧ ಗಂಟೆ 1 ತಾಸು ಕೇಳು ಕ್ಲಾಸ್, ಇಲ್ಲಾಂದ್ರೆ ಯು ಕ್ಯಾನ್ ಲೀವ್ ದ ಕ್ಲಾಸ್. ನಾನು ಹೇಳ್ತಾ ಇದ್ದೀನಿ, ರಿಕ್ವೆಸ್ಟ್ ಮಾಡ್ಕೊತೀನಿ, ಮತ್ತು ಒಂದೋಗಿ ಇನ್ನೊಂದು ಆಗಬಾರ್ದು. ಓಕೆ, ಐ ಆಮ್ ರಿಕ್ವೆಸ್ಟಿಂಗ್ ಯು. ಎಷ್ಟಾಯ್ತು ಅಷ್ಟು ತಾಳ್ಮೆಂದು ಕೊಡ್ರಿ. ನಾನು ಐ ವಾಸ್ ಆಲ್ಸೋ ಸ್ಟೂಡೆಂಟ್, ನನಗೂ ಗೊತ್ತಾಗುತ್ತೆ, ಬಟ್ ಟ್ರೈ ಮಾಡಿರಿ. ಕಂಪ್ಲೀಟಾಗಿ ಕಂಟಿನ್ಯೂಸ್ ಆಗಿ ಡಿಸ್ಟರ್ಬ್ ಮಾಡಿಬಿಡ್ರಿ. ಏನೋ ಒಂದು ಟೈಮ್ ಆಗುತ್ತಾ? ಓಕೆ, ಐ ಕ್ಯಾನ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್, ಬಟ್ ಥಿಂಗ್ ಇಸ್ ದಟ್ ಅದೇ ಕಂಟಿನ್ಯೂ ಮಾಡಬಾರ್ದು. Okay, just to copy the figure. These are the switches. I'll be connecting the switches with one another with the help of the links. Okay, links. Okay, these are the processors. Okay, these are the processor. I am using the inside the connection purpose. Okay. Okay, this is all about the distributed memory system. I will be connecting to the one switch to another switch through the bus here. Okay, just to follow this figure. Okay, just on the end I am tapping. Okay, just I am closing the ends with the help of the another link. Okay, at the end of the switches I am connecting to each other with the tapping, means I am closing that at the ends. Okay, with the help of the links. Okay, even I can also connect the one to the this one, and also I will be connecting to the one to the, and also I will be connecting to the this one is the one to this one. Okay, this is all about the this one you call as the figure 1 tridal. Toroidal mesh. This one figure is called as the toroidal mesh. Okay, and also I have the ring type also. Okay, ring type I have the 3 switches connecting to each other with the help of the links, and also even I will connecting these switches to the with the help of the memory processors with the help of the. Okay, here the indication is what here the circles are the switches. Okay, circles are the switches, lines are the links, and also boxes. Okay, what are the boxes there I am using? Those can be considered as the processor or memory. You are connecting the processor or memory with one another with the help of the links. Okay, and even you are connecting to the with another with the help of the switches also. Okay, these switches can be connected to each other with the help of the links only. Here I have the how many switches I have here? 9 switches here. Okay, I am having here circle is what here the switches, and the lines are called as the links. Okay, boxes. Okay, what are the boxes I am using here? This can be called as the processor. Okay, this can be connected to processor. Okay, okay. Usually the figure. This one is the figure for the ring type. Ring type. Okay, usually we have the seen the ring type. In the ring type we have the 3 processors. Okay, in the ring type we have the three processors. These are connected to each other with the help of the links. Even will be connecting to the one switch to the another switch with the help of the links also. Okay, usually in the customer will be considering the power of the rings. Okay, power of the toroidal mesh. Okay, toroidal mesh will be considered with the help of the only connections between the switch to switch. Okay, will not consider the switch to memory, switch to processor. Okay, usually the how many switches are here? 9 switches. Okay, just to connect here the how many switches are there? 9 switches. Okay, 9 switches. Okay, these are the switches. Okay, 1 2 3 4 5 6 7 8 9. Okay, in the 9 switches. Okay, 9 switches, and even I have the 6. I have the I have the 12 links. Okay, 12 links also. Okay, 12 links. Okay, I am connecting to the switches one another by the with the help of the links. Okay, how many links are there? 12 here. 1 2 3 4 5 6 7 8 9. Okay, 9 is here. Okay, 9 plus 6. Okay, how many are there? 9. Okay, 9 11 10 11 12. Okay, just to check it. 1 2. Okay, 1 2 3 4 5 6 7 8 9 10 11 12. Okay, 12 links are there. Okay, 12 links are there. Around how many links? Okay, 12 links are there. 9 switches are there. How many switches are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 9 switches are there. And also V1 will be having the links. How many links are there? Connecting links here the only 6. Okay, because we are connecting the processor. Okay, we are connecting the processor memory with the, to the links. Okay, to the switches with the help of these are the links. Okay, how many are there? 6. How many are there? 6. Okay, 6. Okay, okay. How many? This becomes what here? The 27. Okay, here the in the ring. Okay, in the ring how many switches are there? In the ring how many switches are there? 3. 1, 2, 3. 1, 2, 3. Okay, these are the interconnections. Okay, 1, 2, 3, 4, 5, 6. Okay, these are the 6 are the interconnections. Okay, usually the power of the model. Okay, power of the model. Okay, ring model or whatever it may be. Toroidal mesh. Okay, usually will be measured with the help of only the customer is what here the only count the connections between the switch to switch. Don't count the connections between the switch to memory, switch to processor. Okay, usually will consider the here the customer is what power of the mesh, power of the ring usually considered to be what is the connections between the switch to switch. How many are the switch to switch here? 1, 2, 3. Okay, these to be 3 cannot consider. Okay, there the power of this one is considered to be instead of 6 will be considering the 3 only. Okay, instead of 6 we will be considering the 3 only. But here the toroidal mesh we have the around the 27 links. Okay, 27 links to connections with each other. But here the we will be considering only the switching connection between one switch to another switch. So that we have the around the 18. Okay. Around the 18 okay links. Okay, these are the links. Okay, okay, these are the 12 links are there. Okay, 1, 2, 3, 4, 5, 6, 12 are there. But these are also connections. Okay, for connecting the processor. Okay, connecting the processor we have the 6 also. Here also 6. Okay, sorry, this one. Okay, 1, 2, 3. Okay, this is the 4, 5, 6. Okay, this is the at the end of the switches will be tapping. Okay, we'll closing that switches with the help of some interconnections. Okay, the wires. Okay, what are the switch links? Okay, this will be considered here. How many are there? 12 plus 6. How many? 18. The power of the toroidal mesh is what here the 18. But the power of the ring is what here the only 3 because the interconnections between the switches we are considering, not the processor also. Okay. Okay, main advantage of this one is the distributed memory interconnects here the mainly it's superior to simple to bus. Okay, and even it allows the simultaneous communication between the one device to the another device, one switch, one memory to the another memory, and even one core to the another core also. Okay, it is the communications schemes are usually somewhat processors will be using here. What are the processors are using? Somewhat its connection is what highly good. Okay, because of the we will be using what here the interconnection. Okay, interconnects. Okay, for the interconnects usually the links usually in the bidirectional only. You should remember bidirectional. And also we have the if there are number of processors, how many processors are there? P numbers of processors are there. If the P number of processors, then definitely I would have get the how many P numbers of switches. Yeah, how many processors are 1, 2, 3. Okay, 1, 2, 3. 3 switches. 3 processors are there. So that I have the interconnection between the one processor to another processor with the help of the switches and also links. How many are there? 6. Okay. If I have the processors 3. Okay. In the ring we have. If I have the processor 3, definitely I would have the links. Okay. One to another with the double. Okay. P square. Sorry. 2p. Okay. 2p. Okay. This is nothing but the 2p for the ring purpose. Even you can also calculate to the toroidal mesh also. There will get the double also. Okay, there also you will get the double. If there are how many processors are in the toroidal? 6 are there. Oh, sorry, 9 are there. So that I will be getting the interconnections to the one another with the help of the double. 2p is nothing but the 9 to the 18. So that I have the 18 interconnections also. Here I proved here. So that in the ring mesh I have the 3 processors. So that I have the interconnections around the 6. But in the toroidal mesh I have the 9 Okay, 9 processors are there, so that I will get the double for that one. It's 9 to the 18 connections. Okay, this is all about the distributed memory interconnects. Okay, just to take the heading. Okay, even the mesh. Okay, usually the possible simultaneous communication between the mesh is more compared to the ring. Here the possible connections here will be having the linking. Okay, with the very less compared to the mesh. Mesh will have the so many connections. Okay, we can interconnect the one another. Okay. Okay, just take the heading as the distributed memory interconnects. Okay, distributed memory interconnects. Distributed memory interconnects. Take the heading as the distributed memory interconnects. Okay, there are two types in the distributed memory interconnects. One is what? Direct interconnects. Another one is what? Indirect interconnects. Indirect interconnects. One is what? Direct interconnects. Another one is what? Indirect interconnects. Okay. Indirect interconnects. Indirect interconnects. Okay. Just to consider first one as the direct interconnects. Okay. Consider the first one as the direct interconnects. Okay. In the direct interconnect, each switch is directly connected to the processor or memory, directly connected to the processor in the slash minus directly processor memory. Okay, directly connected to the processor memory pair, and the switches are connected to each other. Usually we will do the what here, the connections between the processors, usually processor memory, and even will connect to the one another with the help of the processor memory pair, and also switches are connected to each other. Okay, switches usually one another will be connecting. Okay, you have to be moved. Okay, in the below figure, just to copy that figure. Okay, you copy those two figures. Okay, first one is what? A ring type. Another one is what? Toroidal mesh. Okay, toroidal mesh. Somewhat it's a torus figure. Okay, torus gothal jodex sign. Adi tara kanni kaantadanta aa tara ಹೆಸರಿಟ್ಟಿನ ಅಷ್ಟೇ ಅವನು. Toroidal mesh. Okay, there is no meaning of that. Just it's looking like a torus jodex sign ಕಾಣ್ತದಂತ ಅದು ಸ್ಲೇಕ ಅವ ಹಂಗೆ ಇಟ್ಟನ ಹೆಸರು. Okay, ಅದಕ್ಕೆ ಮತ್ತೆ ಆರ್ಡರ್ ಮಾಡಬೇಡ. Okay, that's the ring type. Okay, just to copy the figures. Okay, 1 and 2. Okay, ring type first, then the second one is what? Toroidal mesh. Figure. Copy the figure, whatever I written on the board. Okay, whatever you will be showing here in the classroom. Okay, your concentration on the class and even your negligence to the class, those will impact in the next year. Okay, that will be given back. Whoever it may be, whoever here in the classroom, whoever in the very silent and you are following the classroom, definitely they will get the add-on. Okay, they will be giving the good whatever it may be, interval, whatever it may be. But thing is that if you show any, I will not say anything. Okay, those will be reflected on the next. Okay, I hope you all followed copied that figure. Okay, in these circles are circle and bardu switches and baridi. In the above figure, circles are bardinala. Circles are switches. 0 and bardu switches and baridi. Lines links and link baridi. Okay, even you can give the box. Okay, whatever it this can be processor or memory. Here I am considering the only processor. Okay, I am connecting to the processor, one processor to the another processor with the help of the links. I hope you all have copied that one. Okay, we can measure the power of the direct interconnect with the number of links. ಡೈರೆಕ್ಟ್ ಇಂಟರ್ಕನೆಕ್ಟ್ ವಿತ್ ದ ನಂಬರ್ ಆಫ್ ಲಿಂಕ್ಸ್. ಒಂದಕ್ಕೊಂದು ಲಿಂಕ್ ಏನು ನಾವು ಕನೆಕ್ಟ್ ಮಾಡ್ತೀವಿ ಡೈರೆಕ್ಟಾಗಿ, ಅದರಿಂದ ಪವರ್ ಆಫ್ ದಟ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಮೆಶ್ ಆರ್ ವಾಟ್ ಎವರ್ ದ ರಿಂಗ್ ಕ್ಯಾನ್ ಬಿ ಕ್ಯಾಲ್ಕುಲೇಟೆಡ್. ಓಕೆ. And also when counting the link, we have the customer here. When counting the links, write it. When counting the links, it's customary to consider only. It's customary to customer. Customer is gottattala. Will be having the own idea. Will have the own solution. Okay. Customary to count only the interconnections between the switch to switch. One switch to another switch. Okay. One switch to another switch. Okay. Even, okay, because of the speed of the data flow between the, okay, even, okay, I not taught this one. Okay. Speed between the processor to the switch, and also switch to switch, how this to be connected to each other. Okay. Usually the speed between the processor to switch link may be very different. Okay. Very different from the data flow between the switch to switch. Okay. Usually the data flow between the processor to the switch will be somewhat different from the data flow between the switch to switch. Okay. Switch to switch. Okay. Usually total number of, usually we can get total number, just add the number of processors to number of switch to switch interconnect, to number of processors to number of switch to switch interconnects. Okay. Main advantage of this one is what here, I will get the multiple number of simultaneous communications, and also will get the I can have the more than 3 connections also, because of the in the bus. Okay, sorry, in the ring I was having the only in the bus I was having only 2 interconnects. Okay, either of side. Okay, left side and right side. But in the links I can get the more than 3 interconnects also, more than 3, and means what 4, 5 also I can get it. Okay. Usually the number of possible simultaneous communication between in the mesh is more compared to the ring. Okay, write it. The number of possible simultaneous communications, the number of possible simultaneous communications. Okay, the number of possible simultaneous communications pattern for mesh is more than the ring. Mesh is more than the ring. Okay. I hope you all copied and even following this class. Okay. Next I will switch to the next concept. Okay. Is it clear for you? Okay, shall I move next topic? Okay, next. Usually we'll measure the bandwidth. Okay, bandwidth of the data flow between the link to link with the help of the one connection to another connection. That is to be done. Okay, always with the help of the cross-sectional view of the ring or cross-sectional view of the mesh. Okay, if you cut the cross-section of the ring, or even if you cut the cross-section of that mesh, toroidal mesh, definitely will see the each and every nodes of the interconnections of that particular ring or mesh. Okay, this is to be done with the halving the ring or halving the toroidal mesh into 2 halves. Okay, 2 halves. When cutting to the halves. Okay, cutting to the ring or toroidal mesh into 2 parts. One we call the halves. Okay, first hall one, second hall. Okay, we'll see what that one. This all consists of only the processor of having the names as the A only. Okay, this all consists of the processor of having the name as the B. Okay, these to be connected to each other with the help of the two links here, the A to B and the A to B only. Okay, A to B and A to B. But these to be connected to each other. But thing is that here the halls are connected to each other with the help of only two interconnections only. With the two interconnections only, 1 and 2. Okay, these are the first hall, this one the second hall here. Okay, these two halls are connected to each other with the help of only two interconnects. That one he calls the A to B and A to B. These are not considered to be connections here. Okay, these are not considered to be for counting for calculating the bandwidth. Okay, the only thing is that 1 to 1. Okay, this is the first hall, this is the second hall. Okay, this is the first hall, second one, this is the second hall. These two halls are connected to each other with the help of this link. Okay, this link. There are how many links are there? Only 2 links are there. That's what we have the bandwidth is around the 2. And even I can also have the ring purpose. As this one is, I can write this one is the with the help of the different type A, B. Okay. This side is what here the name of the A only. This side is having the name as the B processors. Okay, B processors. Okay, these to be connected to each other. Okay, these to be connected to each other. Sorry, A B sorry, A B. This is the A B. This one B B. This one B. Okay. Okay, here we are connecting to each other. Okay, how many are there? 1, 2, 3, 4. Okay, these 4s are to be connected to one another with the help of. Okay, even we can also connect this one we will not consider. Okay, for the counting the bandwidth. But for counting the bandwidth, we will consider the only 4 links are there. One is what here the 1, 2, 3, 4 only. Okay. Okay, usually the bisection. Okay, what we are doing here, while calculating the bisection of that particular mesh or particular bandwidth, usually we are removing the number of connections. We are removing the number of connections. Yes, ಇದು ಮೊದಲ 27 ಇದ್ದು ಹೌದಾ 27 something. We connect removed. Okay, somewhat we removed the and even connect make it is what here the only the 4 here. Only even this in this ring type only we have the only 2 types because of the here the we are missing. Okay, we are bisection will usually get got the by removing the some interconnection between the processor to processor and even memory to memory also. Okay, usually the bisection of the toroidal mesh can be explained with the help of the one figure. That one we call the shown. Okay, I'll be writing that figure. Okay, okay, how many are there? 16. Okay, 16 to be connected to each other. Okay, first connected to each other, one another connect to each other. Okay, just to leave this cross section. Okay, this type only one side, and also you connect these 8 together. Okay, with the help of the switches. Okay, with the help of the switches. Okay, and even I can wrap the end of these switches okay, collection of these processors with the help of the one link. Okay, and even I can also connect these processors or memories with the help of the one interconnect. Okay, and even I can also just to connect. Okay, this to be wrapped. Okay, this to be at the end of this to be connected, okay, this to be wrapped with the help of the some links, okay. This one called the bisection of the toroidal mesh, bisection of the toroidal mesh, okay. Copy that figure, okay. ಆಯ್ಕೊಡ್ರಿ ಬರ್ಕೊಡ್ರಿ Okay, bandwidth. Okay, usually see in the bandwidth is nothing but the rate at which the data is transmitting between the one process to the. Hey, start when you will give the seminars. Okay, I want you to give the seminars. Okay, I will prepare you in such a way that wherever you will go, definitely you can easily give the seminars. Hey, shh. Okay, wherever you will go. Hey, wherever you will go, usually you can give the easily, okay, seminar. In such a way, I'll prepare you seminars, okay, for you. I'll give the some tips. Even you can give the of your own seminar wherever you go. Okay, this will helpful for your clearing the interviews also. Okay. Confidence will give the seminars. Seminars will usually give the confidence. Okay, that confidence can clear your interviews. Okay, please understand what we are saying here. Okay. I hope you all copied this one. Okay. Okay, bandwidth. Okay, bandwidth is nothing but the rate of data transfer between the rate of the data transfer between the one switch to another switch, or even data processor to the switch. Okay, this one we call as the bandwidth. Bandwidth is nothing but the rate at which the data transfer takes place between the switch to switch and even the switch to the processor. Okay, switch to the processor. This one we call as the bandwidth. Okay. Bandwidth of the link array, okay. Usually the bandwidth usually give the in the megabytes, okay. Megabytes, okay. Megabytes are MB per seconds, okay. MB per seconds, megabytes per second also. Even, okay, the bisection of this bandwidth is usually given measure to the network quality, okay. Network quality, how my quality of this network is good, okay. If I measure the bandwidth, definitely I'll get the I can get the quality of that, okay, quality of that mesh, quality of that network, okay. Usually the quality of the network is based on the bandwidth of that particular network, okay. Usually the bandwidth for the okay, this ring and mesh I shown here, okay, this is usually 2, there we will get the around 4 here, okay. Next topic is here. Okay, usually it's impractical, okay. Usually the number of connections would be in the particular only 4 or 3, okay. Usually you can get it. If I get the more than 3 or 4 connections, it's not possible to handle that programmer, okay. It's not possible. Usually these can be handled by only the autonomous, okay, autonomous systems, okay. But here in this parallel computing we have the only the 3, okay. We have the switches with have the only 3 to 4 connections. If I have the more than 3 to 4 connections, there I would not able to get the good efficiency. Okay. That one we call as the fully connected network. How to be connected to each other, okay. I has already told you that the connection should be between the switch to connect memory or memory to the switch, whatever it may be. If I have the switch or memory, those two should have to be connected to each other, okay. If I get the more connections fully connected to each other, that is the theoretically okay. You can do it, you can say that this one is having this much of network here, mesh is here, whatever you can say here. But in the practical way, it's not possible to handle that one, okay. That one I will be showing that one fully connected network, how to be connected with memory or processors will one by one another without any single missing, okay. Non connect adre avun non connected mattam without any single miss. Okay, that one will give the somewhat network would be looking to be good. For theoretically it is good, but in practical way we will not get the that much efficiency. Okay, that is impossible to. Okay, that's impractical to get the particular interconnections of the fully connected network here. Okay, how will it be connecting to each other? We'll see one by. Okay, these are the somewhat, okay, figures are very easy. If you remember this much, you can write off your own words. Okay, you can usually write it off your own. Okay, Henry, don't bother. Okay, just you ask me if you have any doubts. Just ask me. Okay, if it is possible for me, I will clear it. Otherwise, I will tell you tomorrow. I will discuss it. Okay, don't murmur there. Please. You have to be attending the 7th semester class. Okay, Kulkarni, Henry, Kulkarni madam, what I am saying? Classroom mele concentration irli. Illandra yad varg hogodu. Yenilla, simple ada. Ond attend ಮಾಡ್ತೀರಾ ನೀವು higher level class nagiddri. ಸಣ್ಣದೊಂದು standardity you should have to maintain, not by me. ನೀವು maintain ಮಾಡಬೇಕು. You know? That will show your what? Your tradition and nimdu tradition ತೋರಿಸ್ತದೆ ನೀವು ಯಾವ ಥರ ಇದ್ದೀರ ಅಂತ. So please, I am requesting you to attend the class very prompt. Okay, don't talk. Simply yourself will talk. Okay, that one you should have to maintain standard. Later we can talk. No, ನೀವೇ ಇಲ್ಲಿ ಕೂತ್ಕೊಂಡು ಮಾತಾಡ್ಬೋದಲ್ಲ. ಬಟ್ ಕ್ಲಾಸ್ ಹೇಳೋ ಒಂದು ಅರ್ಧ ಗಂಟೆ 7 ಸೆಮ್ ಆಗಿದ್ರಿ ಅರ್ಧ ಗಂಟೆ ಕ್ಲಾಸ್ ಹೇಳೋದ್ರೆ ಹೇಳ್ತೀನಿ ನಾನು ಜಾಸ್ತಿ ಹೇಳಲ್ಲ. ಕರೆಕ್ಟಾಗಿ ಅಟೆಂಡ್ ಮಾಡಿ. ರಿಕ್ವೆಸ್ಟ್ ಮಾತಾಡಬೇಡ್ರಿ ಅಂತ ಹೇಳ್ತಿದ್ದೀನಿ, ಆದ್ರೂ ಮಾತಾಡ್ತೀರಿ ನೀವು. ಏನು ರಿಕ್ವೆಸ್ಟ್ ಹೇಳ್ತಿದ್ದೀನಿ, ಅಷ್ಟಕ್ಕೆ మీరు ಇನ್ನೂ ಕಂಟಿನ್ಯೂ ಮಾಡ್ತಿದ್ದೀರಂದ್ರೆ ನೋಡಿರಿ. ಓಕೆ, ನಾನು ಏನಾದ್ರು ಹೇಳಿದ ಕ್ಲಾಸ್ ತಿಳಿಲಿಲ್ಲ ಅಂದ್ರೆ ಯು ಕ್ಯಾನ್ ಸ್ಟಾಪ್ ದೇರ್ ಓನ್ಲಿ. ಸರ್ ಯು ಎಕ್ಸ್ಪ್ಲೇನ್ ದಟ್ ಒನ್ ಸೆಕೆಂಡ್. This is a somewhat completely theoretical subject. I am covering all the concepts here without I'm not missing any single line also. Just I am referring each and every line I am explaining here. I'll teach you for at least 2 to 3 models without single line missing. Okay. Later I'll be teaching you the some 2 models, 4th and 5th of models. Okay. Definitely you score more than 80 marks here. Okay. This is very easy subject. You need to write theoretical. Okay. As I already told you that these are the fully interconnected network. Okay. I'll be connecting to each other. Okay. 1, 2, 3, 4, 5, 6. Okay. Done na? Okay, I need to be connect to the each. ಇದು ಎರಡಕ್ಕಾಯ್ತು. ಮತ್ತೆ ನೆಕ್ಸ್ಟ್ ಇದಕ್ಕೆ ಆಮೇಲೆ ಇದಕ್ಕೆ. Okay, I need to connect the each and every processor without any single miss. Okay, fully this one we call it fully connected network. This is impractical to you. In theoretically it is possible. I am solving here. Theoretically it's possible. Impractical to use in the practical way. Okay, just I am showing that one. And also I could be connecting to each other. This one is connected to each other. Okay, just to connect to each other. Okay. And even this one is to be connected, this one is to be connected, this one is to be connected. I hope all of no, I left here. One more, that one is fine. Completed. Okay. This is the fully connected network. Okay. Figure is what here, the fully connected network. Theoretically best it's possible, okay, in interconnection of the fully network. Okay, in practical it's impractical to get this fully connected networks. Okay. Okay, I'll consider next topic, next concept here, hypercubes. Okay, hypercubes. Hypercubes is one of the easiest concept. Okay, just to if you draw the figures easy, then you can write off your own words. Okay. Am I audible for you? Huh? Am I audible? Am I audible? Then why are you making noise? Huh? ನಾನು ಮಾತಾಡೋದು ನಿಮ್ಗೆ ಕೇಳಿಸ್ತಿತ್ತಂದ್ರೆ ಸೈಲೆಂಟ್ ಆಗಿ ಕೂತ್ಕೊಂಡು ಕ್ಲಾಸ್ ಕೇಳಿ ಆಮೇಲೆ ಮಾತಾಡ್ರಿ. Okay, this is the one dimensional. Okay, this is the one dimensional. This is the two dimensional. Okay, if I have the 4 cubes. Okay, if I have the 4 cubes here, this one is called as the 2-dimensional. Figure B is what here? 2-dimensional. Okay. If I have the, if I use the, okay, if I have the for 2-dimensional cubes here, then I'll get the 3-dimensional figure also. Okay. That one will be connected to each other. This one is called as the 3-dimensional. This one is the 3-dimensional. Okay, these are the hypercubes. Okay, these are the hypercubes. This is what somewhat it says ring type connections, whatever we will be using. They are using some networks. No. Similarly, we have the 1-dimensional, 2-dimensional, and even we have the 3-dimensional also. Hypercubes is the highly connected to direct interconnect that has been used to actual systems. Okay. Usually hypercubes are built indirectly. Okay, 1-dimensional hypercube are used fully connected to two processors here. 1-dimensional we are using what are the 2 processors connected to each other. In the 2-dimensional we are using the 2 1-dimensionals. In the 2-dimensional hypercube we are using the 2 1-dimensional cubes here. In the 3-dimensional we are using the 2-dimensional. Okay, 2-dimensional hypercubes in order to get the 3-dimensional hypercubes. Okay, this is all about the explanation. Okay, and also we have the some. Okay, usually the hypercubes are dimensions. Hypercubes dimensions usually given in the with the help of the D. With the help of the D. Okay, dimensions. Usually the hypercube dimensions are expressed. Okay, not given the name as the D. If I have the P number of processors, definitely I would get the 2 to the power of D number of nodes here. 2 to the power of D number of nodes here. D is what the number of dimensional. Okay, if I have the 2-dimensional for the processors, how many? If for example, if I have the 1-dimensional, okay, put the D as the 1. Definitely, how many processors I am having there in the 1-dimensional? 2 processors. Okay, in the for 2-dimensional we have the, if I put the D as the 2-dimensional 2, then I would have the how many processors? 4 there. 4. If I have the 3-dimensional, 3-dimensional, definitely I would have the 2 to the power of 3. It's nothing but the 8 processors I am having here. Just you look at this one, in that 3-dimensional hypercube, there I am having the how many processors? 8 cubes are there. Okay, this is all about the hypercube. Okay, there is a one processor, there is some equation is there. Okay, switches must be powerful. Okay, compared to this hypercubes. Okay, usually this can be connected to the explained with the help of the some logarithm equation is 1 plus D equals to 1 plus D equals to 1 plus of logarithm of base 2 of having the processor P. Okay, this is the, in order to get the 1-dimensional, okay, how many dimensional in the hypercube I am having, how many, okay, switches must be used, power of that particular hypercube can be calculated with the help of this number of processors and switches there. Okay, next topic, very easy, last topic is there. ನಂದು ಇಷ್ಟು ಮುಗಿಸ್ಬೇಕು ಇವತ್ತ, ನಾನು ಪ್ರಿಪೇರ್ ಆಗಿ ಬಂದೀನಿ. 2 ಮಾಡ್ಯೂಲ್ ಹೇಳ್ಬೇಕು ನಾನು ಕಂಪ್ಲೀಟ್ ಫಾಸ್ಟಾಗಿ ಮುಗಿದ್ರೆ ನೀವು ಆಮೇಲೆ ಬರಲ್ಲ ಕ್ಲಾಸಿಗೆ, ಅದ್ರ ಸಲಕ್ಕೆ ಐ ನೀಡ್ ಬಿ. Okay, next we'll switch the indirect interconnects. Till now we have seen how much, what is that? Direct interconnects. Okay, direct interconnect. In the direct interconnect we have seen the what are the bandwidth, we have seen that, cross view I have seen that, and also even we have seen the hypercube also, and also we have seen the ring and the toroidal mesh also, okay, in the direct memory interconnects. Now we will consider the next topic is here the indirect interconnects, okay, indirect memory interconnects. If you are following my class, you can continue, okay, otherwise stop me there only, just tell me to explain once again, okay, I will explain. Is it clear for you? I hope you are following this. Okay, now we will consider let us consider the indirect interconnects. Okay, this is the also, okay, indirect interconnect is this is the alternative to the direct interconnection, direct memory interconnections, okay, direct memory interconnection. This is an alternative path, okay, alternative substitute. Okay, even we are using the switches may not be connected to processor. Usually we are not using any switches here, okay. Instead of using the switch, separate switches, we will be using some hub, okay. In the hub only we will have the so many switches are there, okay. In the hub only we will have the so many switches. In the separate switches will not use here, okay. In the indirect interconnection will not use the separate switches, separate circles, okay. Here I will be using the some hub, okay, some type of hub. There I will get will have the so many switches, okay. These switches are used to connect to the processor or memories one another with the indirectly, okay. Just only I have the some figure here, okay. Just to copy this figure, this much is enough for you. Okay, here I have the how many processors? 4 processors I am having here. This is what is I already told you, this is what a switching network. Okay, this is the switching network. I have here the number of switches here in the one ellanu balastu switches irtava. There I will be connecting these switches with to the processors, okay, to the processors, processor P1, P2, P3, P4, okay. And also I will be connecting to the second processor also unidirectional, okay. These are connections what I am showing here, the links are the unidirectional, these are not a bidirectional, okay. This switch to a processor, okay. The processor will have the two links here. One is what incoming switch, incoming link, another one is the outgoing link, and one is the what incoming link, another one is what outgoing link. Okay, these processors are connected to each other with the help of the switchboard. That's nothing but switch network here. Okay, this is what you call the generic indirect network. Okay, this figure is what generic indirect network. Okay, generic indirect network. Okay, in the generic indirect network you have the only one switch network. Thereafter I will be connecting to the one processor to another processor or processors with the help of the links. Okay, these links will be having the this processor will have the two links are there. One is what incoming link, another one is what here outgoing link. Okay, how many processors are there? 4 processors are there. 8 links are there. 8 links are. One is what here the incoming link, another one is the outgoing link. Okay. Okay, usually I would be having the, this is not a 4, okay, this should be n, okay, sorry, this is n. How many? N numbers of process I can connect to the switch network more than the 4 also, process also can I connect to the switch with the help of the switching network, okay. Usually in the switch I will be connecting only the 4 processors, okay, at the same time, 4 or 5, but more than 5 I cannot connect. But in the switching network I will be using in the indirect switching network I connect the more than 4 processors also with the help of switching network. I hope you all following this one, okay. Okay, the best example for the generic indirect network is what here, the omega crossbar and the omega networks. Okay, there are 2 networks in the indirect interconnections, indirect memory interconnections. There are 2. Okay, there are 2 networks are there. One is what calls the crossbar. Okay, another one is the omega network. Okay, these 2 are figures. So if you practice these 2 figures, then definitely you can write off your own. Okay, I'll be writing the figure. Okay, just to focus on the figure. I'll be explaining within 2 to 3 minutes. I'll be explaining these 2 also. Okay. Okay. I hope you all followed this one. Shall I erase this? Huh? Huh? Only crossbar and ಇನ್ನೊಂದು ಎರಡು ಅದ. Hey, crossbar. Okay. We'll continue the tomorrow. Okay. By Okay, yes, very okay. ಏನಾದ್ರು ಫಾಲೋ ಆಗ್ತಿದ್ದಾನ ಕ್ಲಾಸು, ಏನಾದರೂ ರಾಂಗ್ ಆಗ್ತಿದ್ದಾನ, ನಿಮಗೆಲ್ಲಾದ್ರೂ ತಿಳಿಲಿಲ್ಲ ಕೇಳ್ರಿ, ಸುಮ್ಮನೆ ಬಿಡಬೇಡ್ರಿ. ಮತ್ತೆ ಏನಾದ್ರು ನೋಟ್ಸ್ ಬೇಕಾದ್ರೆ ಬಂದು ಅಪ್ರೋಚ್ ಮಾಡಿರಿ. ಓಕೆ, ಕ್ವಶನ್ ಪೇಪರ್ಸ್ ಇಲ್ಲ, ಮಾಡಲ್ ಕ್ವಶನ್ಸ್ ಪೇಪರ್ ಬರ್ತಿದಾವ, ಅವ್ನು ಕೊಡ್ತಿದ್ದೀನಿ ನಿಮ್ಗೆ. ಐ ಪುಟ್ ಆಲ್ ಇನ್ ದ ಗ್ರೂಪ್ ಓನ್ಲಿ.